On the next hard copy, different rocks form in different ways. Furthermore, we'll have all you need to know about
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by rocks. Did you ever stop to think that the whole world is covered with rocks? And every rock used to be different. When you're looking at a rock, you're looking at history.
Careful.
See, all the rocks in the world used to be melted rocks, what we call molten rocks. Molten. Like this molten rock in here. And do you see the bubble on top? It's from the heat. It's just like the rocks that come out of volcanoes. Rocks like this, rocks like this, rocks like these. See these pits? They were formed by bubbles in liquid rock that came out of a volcano. Now sometimes the rock from volcanoes will come up onto the Earth's surface. Now when these rocks get on the Earth's surface, they push other rocks down. It pushes down on the layers below. Push the old rocks down. Push them down and they'll squeeze together and swirl around. And when they blend together, they form a new type of rock, like the minerals that are swirled together in this piece of marble. Anyway, wind and rain moving over the Earth's surface break rock down into sand. And sometimes enough water will flow through the dust and sand, mix them together, push it around, and it'll dry out again and turn back into rock like these. Good thing I have my safety glasses on. Now this process where rocks are formed, broken down, and reforming as they come out of the molten earth and turn back into dust, into rocks again, has been going on since the world was formed. Billions of years ago. Rocks! Rock! Rocks! Rocks!
And now, Sandy Stone.
I love you, lava, baby.
He'll roll right over your heart
It makes me hurt when you call me dirt.
because he's gritty.
The most beautiful granite on the planet.
Order now.
This is dirt, broken down rocks. Now when microscopic living things get in it, it can turn into rich, dark soil that plants can grow in. So soil comes from dirt, which comes from rocks. See, it's an idea as old as...
As you can see, there are no mighty rocks here now. It's all been reduced to eeny, teeny, tiny bits of sand, reduced by the pounding surf, the merciless storms, weakened by the sun, but mostly by the pounding,
So
pounding,
the sand has
pounding.
been pounded from solid rock. Now that rock was once liquid, molten rock.
Hey, I'm
But
not
now
finished.
it's nothing but
And so what
fine
can the
grains
government
of
do
sand.
about this
In the
pounding,
last
pounding,
ice age,
pounding?
perhaps
In the
40,000
final
years ago.
analysis,
So we're talking about
nothing.
tens of thousands of years.
I'm
This is
talking
not
about
some-
pounding.
this is not-
Different rocks are formed in different ways. All the material in this sandstone once belonged to other rocks. That rocks.
Scientists like to think of 3 types of rock. Now, the first type you might call igneous rock. Igneous rock. Now, igneous comes from the word for fire. You know how you ignite the candle and you have igneous rocks? You know, igneous, ignite, that's from the word for fire. So see how the candle wax drips down the outside of the candle? Well, igneous rocks are often formed when hot lava drips down the outsides of volcanoes, and it cools to form rocks like this granite. See? The next type of rock we call sedimentary rock. Now, sediment, that's silt, mud, goop in rivers. So if you have a river and it's washing sand, mud, or silt, sediment, downstream, well, eventually the river may dry up or drain away, leaving the sediment, the sand, silt, or mud. Now, this sand would be heavy. It crushes down on itself, like this, squeezing itself together. Till eventually, after the water is completely drained away, after a few thousand years, you end up with a rock like this one. See the layers? Sedimentary rock often has layers in it because that's the way sand washes downstream in a river. Now, the last type of rock is sort of a combination of the other two. We call it metamorphic rock. Now, metamorphic means it's changed, it's metamorphosized. So, if you look at this, this is rock that was once sand, but it's been smushed together by huge pressures under very high heat. Pressure and heat, smashing the rock till it's just crushed flat like this. See, heat and pressure formed another rock.
So you think rocks are boring? You think rocks are stupid? Well, it's my job as your guidance counselor to show you that rocks are your friend. Come on, I'll show you.
Ow, hey,
Right here.
mister, let me go. Ow.
Sorry.
No,
Made of
no.
rock.
In fact, your whole school is made of rocks. The foundation, the floor, the walls, the ceiling. And glass. It's made of sand, which is rocks. Are you listening to me?
This is good rock. In different places you get different rocks. Here we've got granite, which is kind of blocky and has cracks in it. Other places you get sandstone, which is more nubby and it's a lot grittier. It erodes away more.
Granite doesn't usually crumble. It's pretty solid rock. Rock climbing's all about is just going up on a rock, feeling rock, you know, basically getting a rush for the day and just having the best time of your life.
Yeah.
Hey, Edward, what are you doing?
Hey, Bill. I'm looking at the patterns on this metamorphic rock.
Oh, yeah. Look at it. It's the product of millions of years and tons of pressure per square meter, thousands of degrees Celsius, crushing these different minerals together into this
Bill.
beautiful... Every rock you see used to be different. Please consider the following. Rocks are always changing all over the world and part of something we call the rock cycle. Now, you can find out for yourself about the rock cycle next time you go walking near a volcano. You'll see hot lava coming right out of the ground and cooling off to form new rocks. Now, the reason we have volcanoes on the Earth is that the Earth's surface, the Earth's crust, is made of gigantic plates of rock called tectonic plates. And the plates are always moving, shifting, even today. So as the plates on the Earth's surface move and shift, they run into each other. Now, when plates bump into each other, one plate gets forced below the other one. And take a look at this. These are our tectonic cookies of science. Now, if one cookie rides over the other, you can see that the cookie underneath gets forced down. And if that were rock, it melts down like lava back into molten rock. And the rocks on top just keep getting older and older. Now, back here, where the cookie crumbles, that's where the new volcanoes form. The molten lava comes up to the surface and makes brand new rocks. The rock cycle's been going on for millions and millions of years. It's great. Well, thank you for joining me on Consider the Following.
Start to understand some of the processes that we see on the surface of the Earth.
See these big cracks? See this big crack? You know where they came from? It was formed when water got in there and freezes, and it expands, split the rock apart, makes the crack get bigger. Happens over and over again, freezing and refreezing, and eventually the whole rock is split right open. And this is lichen. It's actually a plant. It's a fungus and algae that works on the rock, breaking it down, breaks it down. And take a look at this plant. Its roots are growing in there, and they're going to split the rock right open. And eventually, these big rocks get broken down into this fine dust. And this process goes on all day, all the time. Rocks get broken down.
The Student Conservation Association program is a program for young teenagers to get a feeling of outdoors, and they're out here living outdoors and working outdoors.
This is the soil we've been using to fill in the social trails that have been made.
The social trail is like when you try to take shortcuts and then everybody else just follow you and the grass will start wearing out.
Rocks should just be here to support everything down low.
So you can fill it up to put the gravel on top, because when the water comes in, it's gonna push the dirt through the dams right there. And so we're putting gravel here so it'll clog everything up so it'll stay in place like solid ground.
Well, as you can see here, the soil that we're putting down is made out of little bits of gravel and vegetative matter.
Kind of what this whole process is about, is making the full cycle of keeping the plants going and the soil healthy.
We do this to repair the natural setting. Trailways are basically just a passage for you to enjoy nature. The more you go off the trails, the more you're destroying nature.
Rocks rock. Each one has a different story to tell. That is, if rocks could talk. Like this rock. It's called a conglomerate because it's actually made of a bunch of different rocks globbed together. This is sandstone. Sandstone. It breaks apart easily because it's just a collection of sand squished together into a stone. Whoa.
I've got a camera on the end of this pole, and you can see how the action of waves breaks rocks down into sand. Sand that makes sandy beaches, and sand that will one day become soil. Now, this process has been going on for millions of years, and that's why these tiny waves can slowly make rocks into sand and sand into soil.
Many strange rock formations are often partly the result of the cutting action of sand, hurled against the hard rock by the wind.
I'm Chuck Natsahara. I'm a soil scientist with the Natural Resources Conservation Service.
Okay, I'm gonna take it up.
These are the tools of a soil scientist. I have an auger here that I can use to drill down through a profile.
Still sand?
Oh,
it's
you guys
reddish
kind of
up here.
red.
But it went down to gray.
I have a spade here that I can use to dig down and see if you can get all the way down here to where it really breaks out. And I have my knife that I can use to sit and probe and dig out samples. This is a nice profile where we can see how a soil is formed. We can see the different layers or the different horizons. Soils are forming all the time. We have rocks here that are weathering down to sands and being mixed with old pieces of wood and roots. And as they all combine together, they produce soil. By describing and mapping soils, we have a better idea of the best ways to use our soils, whether it's for crop production or forest production. By knowing the different properties that we investigate, we can find out which are the best ways to utilize our soils.
This is a soil lab. Now suppose we could dig straight down into the soil, pick it up, and look at it from the side, like this. Well, this is called a profile, and these are soil profiles. You can see that soil has layers. Like up here, there are a lot of living things. Then as we dig down, the soil turns lighter, and eventually we find this layer of clay, which is red. Probably has iron in it, like rust is red. Now here is farmland, and that's topsoil. It has a lot of living things in it, and a lot of plants will grow up here. But if we go down, we see that it's different colored soil, and plants probably wouldn't grow as well. So topsoil is thin, and we have to take care of it. Now here is dust, and the dust came from rocks. As we dig deeper, we find small rocks. We keep going down, slightly larger rocks, then slightly larger than that rocks, and then big rocks. See, soil comes from rocks. It always has. Soil is everywhere.
New soil bars.
They're crunchy and they're natural, they're dirty all the way. Yes, new soil bars, the rockin' is candy of the day. Soil bars, soil bars, soil bars.
100% natural rocks and soil. Try one today. Soil bars not responsible for lost teeth or digestion problems incurred by ingesting soil or rocks. For entertainment purposes only.
She'll be flooding down the mountain when she comes. That looks like sand erosion. Doesn't it look like wind erosion there? Sort of a...
Hey, Bill, why are you playing in the sand?
Oh, I'm getting ready to recreate one of the greatest floods in geologic history.
Oh, you mean that flood over 16,000 years ago in the eastern part of Washington State? The one where that gigantically huge glacier broke and spilled a gigantically huge amount of water that washed away millions of tons of sediment, exposing the volcanic rock underneath? That flood?
Yeah, that's the one. Boy, you sure know your ancient floods.
Who doesn't?
A vast lake formed behind gigantic walls of ice. From time to time, the ice dams gave way. Enormous floods scoured the volcanic landscape, displacing tons of rocks and soil as the water flowed westward to the sea.
Whoa! Hey, look, it worked!
In what is now Washington State, a huge waterfall was formed. The reshaped rocks of the dry falls remain today, speaking silently of the torrent's power.
The wind can change the land. In the desert, it blows sand, changing the shape of the low, sandy hills.
Universal Pictures proudly presents Rocky XXXVII. Don't take it for granted.
See these little pits? These are bubbles that came out of a volcano. See the pits in this rock? Well, they started out as bubbles in a volcano. Yeah, this rock was once a liquid.
Diamonds are formed in the necks of volcanoes. Carbon will crystallize at terrific pressure and heat, and that's how diamonds are formed. My job as a diamond cutter is to take the rough crystal like this and to make it into a gemstone like this. Diamond is the hardest substance known to man, and only diamond will cut diamond. This is diamond that has been ground into a powder. We put the diamond powder on the edge of the blade, and now we can cut the diamond. Now that's a rock.
The only difference between this piece of coal and this diamond are millions of years and tons of pressure per square meter. See, they're both made of carbon. The carbon in this charcoal absorbs almost all the light that hits it. It's black. But the carbon in this diamond that's been crushed into hot, molten rock deep inside the earth has turned into this beautiful, clear gem that sends light bouncing in all these directions. That's why humans have coveted diamonds for centuries, for its fiery beauty and hardness.
You can make crystals using a lid from a large jar, some construction paper, some scissors, some hot water, and some Epsom salt. You can find Epsom salt at almost any drugstore.
Okay.
First, cut the construction paper so it fits inside the lid. There. Now put some Epsom salt in some hot water. Looks like I need a little bit more water. Now stir it. Now pour some of the Epsom salt water into the lid. Make sure it just barely covers the construction paper. Now, let it sit for about a day. Cool. See? crystals form because the molecules in the Epsom salt moved toward each other as the water evaporated. They formed patterns, just like rocks. See? It's crystal clear.
So you see, rocks are your friend!
Rocks are formed in many different ways. I want to talk about them if that's okay. Made by pressure, heat, and water, we rock hard, but rocks rock harder. Igneous rocks form inside the ground, made when melted rocks cool down. Lava, pumice, scraping granite, all hard rocks sitting on this planet. Made by pressure, heat, and water, we rock hard, but rocks rock harder. Heat and pressure get their kicks, making rocks called metamorphic. Goes down deep inside the earth, a hot, hard place to have your birth. Sedimentary rocks are made from dust, like sandstone, color gray, and rust. Wind and water break them down, cut big canyons in the ground. Made from pressure, heat, and water, we rock hard, but rocks rock harder. But rocks rock harder.
Well, that's our show. Thanks for watching. You'll excuse me. I've got some igneous rock crystal cleavage planes to evaluate. See ya!
Produced in association with the National Science Foundation.
Well, that's our show. Thanks for watching. You'll excuse me. I've got some plastic flow of metamorphic rocks to investigate. See ya! Well, that's our show. Thanks for watching. You'll excuse me. I've got some igneous, metamorphic, and sedimentary rock to investigate. See ya! Not a bad day.
You forgot to close the doorbell.
Get that later.
Okay.
Rock! Rock!
Careful.
That's all I have in me.